Each picture you have here, all of these, I only have 3 of them, are regular polygons inscribed and circumscribed about a circle of radius 1. So like the circle has a radius of 1, and so the circumference of the circle would be what?
Pi.
Oh wait, 2 pi. 2 pi, right? The circumference of the circle is 2 pi. Hold on. Time out, guys. Okay, you gotta really think today. So this is what happens is as the polygons get more sides, even though the circle continues to have a radius of 2 pi, circumference of 2 pi, the perimeters of the shapes, the inside perimeter is going to be smaller than pi, and the outside perimeter is going to be smaller than 2 pi, and the outside perimeter is going to be a little bit bigger than 2 pi.
Right?
Oh, yeah. But as you add more sides in, here, like now, the hexagon or the pentagon is more circular, so the perimeter is going to have a closer value to 2 pi, but the inside one's an underestimate, and the outside one's an overestimate. And so, as you build in more sides, like if I make another circle with a radius of 1, we'll just call this a radius of 1. Let's say I put in, a dodecagon. You guys got to pay attention. So if I put in a dodecagon, well, okay. It's going to have less. Whoa. Oh, that's pretty good. Impressive. Okay, and then that was great. That was great. And then the outside one. Almost exactly. Okay, so you guys, you get the idea? Yeah. So you can calculate the outside perimeter and calculate the inside perimeter and maybe average them? Yeah, that's what I'm thinking. Yeah. You can get a pretty good estimate of pi. Of 2 pi, right? Wait, if you have 2 pi. And then you divide it by 2. Why not? Okay, and then you what? Divide it by 2. Then you divide it by 2. And you see how close you can get to pi. Raise your hand, really first. Because the circumference of this circle, I made 2 pi because it's easier to work with a radius of 1 when we learn trig. Okay, get it.
Did our forefathers just go with the biggest polygon they could get?
I don't really know why I thought of this, but I must have read it a long time ago.
They approximate and then they just got really close to pi because they had so many sides on their polygon.
So there's some history to this. For some reason, I just was thinking of something interesting to do today, and I remembered I've done this before, but I don't know why. So I must have maybe read about it. I'd have to look up the history. I don't know it.
That is super sweet.
It's cool though, right? Yeah. So, Kira.
Is there a cool little name for 2 pi where it's like another Greek letter? Thank you. Yeah.
Yeah, Lily. So this is the required part. I know there's got to be a buy-in for you guys. This is the required part. But then the bonus part is use a polygon, at least 12 sides, and then apply the trig to figure out how to calculate the perimeter of the inner polygon and the outer polygon and get the average and see how close you are to pi and calculate the error.
Can you do one problem for that?
Yeah, I got to do a problem because you haven't used trig. Abby. So we don't need trig on everything.
Is this homework?
This is a class work right now.
But will it be on? If you don't finish.
Yeah, it'll be homework. But I think we're gonna get a lot of it done. Okay. So you guys, you have to let me crash course you on trig, and this is what I'm saying. This is not the best way to learn trig, but we'll talk a little bit more about it later. It's just that I thought you guys would find this interesting.
That is super
So I'm going to just use some things that you know already. You guys have to be quiet, you're just so loud. Okay, so you do know that you know some properties of 30, 60, 90 triangles, right?
Yeah, we start really 30.
You ready? Okay. And so you're going to need a calculator. So I'm going to just have Connor and Kevin and Kristen pass out a calculator per table. So quietly, while they do that, you guys are going to focus here. Okay. Let me just ask you. If this was 1 unit, using your 30, 60, 90s, what is the length of x and what is the length of y? Raise your hand, guys. Okay, somebody I've heard from today. Cole.
X is 0.5 and Y is 0.5 root 3.
Okay, and so, or root 3 over 2, right? Okay, so with your calculator, let's get a decimal approximation of root 3 over 2. Can you do that? Get root 3 over 2?
Yep.
So,
You're upright.
I hate that. 4866 there?
That's what we got to.
Got it? Okay, I'm gonna wait for a minute. Does everybody know what I just did? This is just an approximation, right? This is exact, that's approximate. Totally right that. Kira.
I'm a little confused because on this diagram it indicates that the I'm just like, why? How come on that triangle the hypotenuse is labeled as 1? However, on this one it is not. The hypotenuse is labeled as 1.
Well, it's actually, it depends on your point of view. Like here, if I draw a triangle here, that's the leg, right? But if I draw in this other triangle right here, it's the hypotenuse.
Okay.
Two different triangles. We're going to be looking at, it's a really good observation, two different triangles to do this. We're going to look at this triangle here, where the leg was
The leg
1, and then this one where the hypotenuse was 1. The problem is, this is not a 30, 60, 90 triangle, so we have to learn trig to do more. But, you got it? Okay, so let's go back to the 30, 60, 90. With this 30, 60, 90, you could use trig rules, and you have to learn how to use my calculator, but at the top of your worksheet, you see, when you pronounce it, sine, right? And theta, the Greek letters are traditionally the variables for a trig. So what this means is the trig ratio, the trig words just mean make a ratio. It's like saying make a ratio of two sides of a triangle. That's all it's saying. So you see opposite on the top of your worksheet there? Over hypotenuse. So, and what that means is if I were going to do the sine of 30 degrees, I have to look at 30 degrees, and in reference to 30 degrees, if this is my reference point, this angle, this side is the adjacent side, and this side is the hypotenuse of the triangle. So the left over side is the one that is called the opposite. So in reference to 30, the yellow side is the opposite side. But when you change your point of reference, if my point of reference is 60, Then the adjacent side is here, and the hypotenuse is always the hypotenuse, but now the opposite's over there.
And you know that the smallest angle is the smallest side.
Right. Okay, here. Tyler, Rachel.
So, an easier way to think about that is the angles that is created, the lines, or the line segments that
Form the angle
are not,
are never opposite.
they're never
That's it, exactly. And the hypotenuse never changes.
Right.
But the adjacent and the opposite are always relative to the angle. Right. Okay, Samantha. Okay, great question. This is called right triangle trig. You can't type it in right now, sine of 90 degrees. Just hit sine of 90.
Sine of 90.
Or tangent of 90.
Where's tan? Oh, I see sine 1.
You get errors on some of them, right? Right. So, when you use right triangle trig, you only use it for the non-right angles. It only applies to the angles that aren't right angles. It works because it's too complicated. You need to go to school next year to answer that question. That's a whole other subject.
But she's not going to 20.
Okay. So, according to the directions, these are just directions. In this problem, the sine of 30 would be opposite of 30, which is 0.5, divided by the hypotenuse, which is 1. Now type into your calculator, you guys. 2.5 sine 230, and then hit sine. I'm not sure if you get 0.5, right?
I got syntax.
Okay, so you have to, on this calculator, you have to hit, mine's the reverse. You have to hit sine and then 30. 0.5. Okay, so, listen guys, the reason this is useful is you can calculate any length of a triangle if you know, of a right triangle if you know the angles. Wait, stop. Okay, this is going to be a really good recording. Okay, so if I wanted to find y, if I didn't know that y was this value, I could either change my point of reference and do the cosine of 30, because the cosine of 30 is the adjacent side. You see the notes on the top of your page? Divided by the hypotenuse. So I would be solving for what? Suppose I didn't know it. I would put a variable in. Adjacent side over the hypotenuse. And I would just treat this like a ratio of proportion. So cross multiply. I'm trying to figure out why. Like, what if I didn't know that?
But what if there was a 0.5x wasn't it? Like the hypotenuse is
Raise hands. One at a time. Ben.
So what is the sine?
The sine is just a ratio of two sides of the right triangle. Lily. Yeah, I'm going to practice with you. Kenneth.
So, no matter what the distance of the leg of the hypotenuse, or the opposite of the hypotenuse, it's always going to be 0.5 if the angle is 30?
Because the triangles are similar.
So,
like, what I'm saying is you guys know that y right now for 30, 60, 90 triangles is this. But you only know that about 30, 60, 90s and 45, 45, 90s. But there's a lot of other triangles out there. And so you can't use those properties to find lengths of any other triangles. The trig will find the lengths of all of them. So if you type into your calculator the cosine of 30s, you should get 0.866. So let me give you an example. I'm going to do another example, okay? So
why do you think
you got to let me do a little bit more. I'm going to go to Lily's question. If I wanted to stick with the 30-degree angle, and I wanted to solve for y, in reference to 30, y is the adjacent side. Do you see that?
Oh, please, let's go.
But if I wanted to go to the 60-degree angle instead, in reference to 60, y is the opposite. So I should also be able to say sine of 60 is equal to opposite over hypotenuse, which remains 1, and then solve this as a ratio proportion. Now type in sine of 60.
Oh, then you can find it.
Type, multiplying by.
Okay, then why do you just?
Because it's divided by 1.
Yeah.
So,
Like, you just that's what.
so the way you what you do is, no, it's a good question. So you're solving this ratio proportion, right? So if we actually cross multiply, we say sine of 60 times 1 is equal to 1 times y. So on my calculator, I have to type in 60 first, but on your calculator, you do 60 sine.
No,
you
you
do sine
decide.
60. It just depends on the calculator.
Oh,
So when I type it in, I get the same length. Yeah.
I started like sine 30 times 2, and it gave me 0.8660.
Well,
And it's sine 30 times 2. And then I gave me 1.
no, because when you type in your calculator, sine in your calculator, what you're really typing in is sine of 30 times 2,
Which I did.
which is the sine of 60. What you're meaning to do are 2 sine,
yo, what you have to do, Jack?
that's sine of 60 what you did.
You have to.
Sine of 30, order of operations,
You have
it has
to
the whole
sine
60 first.
30, and then you have to close parentheses, and then you have to get times 2.
Yeah, or put the 2 in front. Abby,
Oh, yeah. So, yeah.
I'm trying to get there.
Okay.
Trying to get there.
Why does it have like as it knows
You have choices. That's the point. The sine of 30 is a ratio, okay? In any 30, 60, 90 triangle. So the sides are always in the same ratio, which you already learned.
and this is only for 36 triangles.
So if I wanted to just do a random triangle, and I just made another right triangle. So here's how you use it, you guys. Suppose I made another right triangle. This only works in right triangle trig. Let's say this was 70, and this was even a different number like 10. If I wanted to find x and y, in reference to 70, y is opposite. Do you guys see that?
Yeah.
So I have a hypotenuse of 10, right?
Sine 70.
So I could say the sine of 70 is equal to opposite, which we don't know, over hypotenuse. Now I can solve a ratio proportion. 10 times the sine of 70
So 76.
should be equal to y.
So 706.
So type in, really. Time out, guys. Yes.
9 point for that.
9.6.
No. Sine of 70 is one number, and then that's a number. So, because it's 10, so 10 times, so for mine, the way I would have to do this older calculator, you'd say, I'd do 70 sine, but you would type in sine of 70, and then you hit equals, and then you multiply by 10, and I get 9.3, about 9.4.
And this only works for right triangles.
Hold on, guys. Do you guys see that?
Yeah, I see that.
So this is about 9.4. I round it. If I use Pythagorean theorem now, I could get x, and if I do trig, I can get x. They should be the same.
Yeah.
So if I did 100 equals 9.4 squared plus x, I would have to subtract 9.4 squared from 100, right? So I'm going to do that. I'm going to do
88.36.
100 minus,
88.
I'm rounding, right? But, oh, square root it. So about 3.4. You guys agree with that? You get that? So, I'm going to wait. Trig tables, you used to have, it used to be about, when I went to high school, I actually used a calculator, surprising, but my older sisters, you would have to look everything up in a table. So there was like, somebody would calculate all the values using a computer, and then they'd publish a table, and then you'd look it up. But watch, guys, right? Can I finish this though? So now I could say in reference to 70 degree x is adjacent.
Okay.
So I should be able to say that cosine of 70 is equal to x over 10.
Oh, we know what x is.
I know. So let's see if it works.
Oh, let me check that.
So cosine of 70.
Let me check this for you. About
And then times 10, right?
yep, it works.
You said the
Wait, no, I said times 10.
It's not the exact same.
So 3.4, right? Okay. Great. Stop talking and raise hands. Kevin.
I'm a little confused about how you find the opposite side of the adjacent side.
Okay. So I think what Mitchell was saying was when you have a reference point angle like 70, the two sides that form it are never opposite.
Yeah.
So it's like Pac-Man. Pac-Man's always eating the opposite side. Okay?
Yeah, I know.
10 is always, the hypotenuse is always the right angle. So opposite changes depending on your reference point. So since I'm using 70, my opposite side is y.
Yeah. But with the y from x. Yeah.
That's just how we name it in the triangle. It's like, why is this my right arm? Somebody decided that. Okay.
Yeah, so x could be the opposite side.
If the angle's 30, x is the opposite side.
No, it's not.
I mean 20.
No, but
It's in reference to the angle.
Yeah.
So in reference to the angle of interest.
Wait, so if you know all the angles, you can just choose.
You could just choose. So you don't have to do the same problem the same way.
I'm a genius.
Okay, Mitchell,
you took the 90-degree angle.
you can't use these ratios with the 90-degree angle. Connor,
Why not? Because the other one.
because that, this only works for acute angles, Paul.
Okay, so I see how this would work for the first two problems on the group sheet, but then when you get to the pentagon.
Okay. So you guys can we go with this and try the pentagon together?
Only works for right triangles, not
This type of trig is right triangle trig. It works for the acute angles in a right triangle. So let's look at the pentagon. Okay?
Wait, how would you even use it in the first part?
Okay, let's look at the triangle. Ready?
Yeah.
In the triangle, I have to find, my goal is to find the perimeter of both triangles. Okay? The big one and the small one. So for example, if I wanted to find the perimeter of, I'm going to build in another triangle here. So if I extend this to here, can you see that I have a right angle here? And so really I have a triangle with this being one, okay? And let's say I want this, and I'm gonna call it X. Okay? I know that this is 30 degrees, because it's an equilateral triangle. Because it's circumscribed and inscribed about, because I made it, all these shapes are regular. I made all regular shapes on your paper. At this point, it's best for regular shapes because they start to look more and more like a circle when you add in more sides. So if I want to find X, in reference to 30, I have opposite and adjacent. Do you see that? I have the opposite and the adjacent, so I would have to say tangent. Look at the top of your page. That's the ratio between the opposite and the adjacent.
Wait, what?
You could just use the old rules, right? But I'm trying to help you practice to learn to use the trig so you see that it really works. So you're right, Samantha, the answer should be root 3, right? We know that, and we want to I'm trying to convince you that the trig works. Okay. So the tangent of 30 would be the 1 divided by x. Do you see that? Because it's opposite of 30 is 1. This time I don't use the hypotenuse. It's adjacent and hypotenuse. Opposite and adjacent, I mean.
What is adjacent mean?
It's the tangent of 30 is equal, or tangent of any angle is adjacent over hypotenuse. So the adjacent is
opposite over.
I'm sorry. It's like I can't talk and write at the same time.
Opposite over.
Opposite. Can't believe I just did that. Over adjacent. Okay. So in reference to 30, the hypotenuse always remains the hypotenuse. So the adjacent is the other side that forms the angle. 1. Okay, so if I were going to do a ratio and proportion, I would cross multiply. I'd say x times the tangent of 30 is equal to 1, right? 1 times 1? Agreed? So I would solve it by dividing by the tangent of 30.
Why is it tan?
Because in this triangle, I don't have the hypotenuse at all. I have a 1 and I want the x, and so the hypotenuse isn't involved. So I'm going to use tangent.
Oh, okay.
So now I have to type in 1 divided by the tangent of 30.
1%.
Okay, so Jack just typed it in and got 1.732. Now what? You know it's the square root of 3, right? From your 3069 triangles. So 3 square root is the same.
What?
So,
It's the square root of 3.
so what's the point of this?
It is cool. Woo! Okay,
I do anything.
so do you guys get that?
Yes, I get that.
Okay, but to find the inner triangle perimeter,
Well,
you have to look at this triangle right here. So, see, here's the other triangle, right? Because if I want to find the inner triangle, I say y. Do you see that?
Oh, you use double.
Well, it's a different.
You have the hypotenuse.
So to find the perimeter of the outer triangle, you guys should know it's 6 square roots of 3. Because it's root 3 plus root, right? And to find the inside triangle, here's my right triangle. Now, so I've got to bring this guy out. I want to find y. So, and this is,
Now the hypotenuse is 1.
now the hypotenuse is 1.
Yeah.
So you would use the
And this angle up here is 60, right? Because it's that same 30, 60, 90. So this is 60. So I have opposite and hypotenuse.
How do you know it's 6?
Because in the original
The last one,
triangle,
yeah,
from the last triangle, it was 60.
Don't you also have the adjacent in the hypotenuse?
Well, I'm trying to get y, but I want the y. I want to know what y is.
Opposite.
But does it? wouldn't
Well,
cos
next-
half?
I don't want this, I want this to get the perimeter. To get the perimeter of the triangle, I want this.
But you
Yeah,
know,
I know,
one
but
half, that's gonna be half.
wouldn't like, both
You're trying to find the
sides,
cosine.
Yeah, you could use
could you
either,
use cosine of 30?
yes. So you could set this up saying
Sin 60.
sine of 60 is equal to y over 1, or you could say cosine of 30 is equal to y over what?
0.86.
So let's look at it.
0.866.
We do. We already know. The reason I picked the triangle you already know is so you understand how it works before you do a triangle that you don't know. So when you type in the cosine of 60,
So it's
0.866.
60 sine. Okay, now, you said it's the same as root 3 over 2, right? So watch, 3 square root divided by 2.
Oh my god.
Times 2, times that by 2.
No, well,
Is that the triangle?
but it's y, right? So y is 0.866, you're right. I would just times it by 6 to get the perimeter of the little triangle, right?
wow.
Okay, Lily.
I think, so, since that, they're both lateral triangles, couldn't you just know that one side was 1.7?
Yes.
That way?
You could have done it without trig, but the problem is, you can't here.
Yeah, you can't do that.
Okay, keep going.
I'm talking about like,
All the other equilateral triangle properties.
no, I can find it without it. You automatically know that
You already know this, what you're saying, I think, is that you know this is root 3, so this whole thing's root 3, right? Because this is also an equilateral triangle. Yes. Oh, but what better way to believe that the trig works than to do it with values that you know should be true? Right? Why would you believe me otherwise? Like I'm showing you using things you've never seen before and getting all the things you know. So trig works.
Oh, it still works.
So it still works
No,
for
like
thousands of years.
the root 3 times 3 still equals
It still works. Still works. I feel like okay. So can I go to this one? I feel like we're gonna have to pick this up on Wednesday.
Yes.
Because it seems like you're interested in it.
I got it.
So what do we have? Is this?
That's it. So can I do one with you? Maybe you could.
Yeah.
Okay. So here we have a pentagon.
Alright.
So the pentagon, we have to use the exterior angle theorem. Or you have to know something about a pentagon to get the exterior angle is 72, so an interior angle is 108.
Yeah.
Right?
So half.
Trust me, you knew that a while ago.
Yeah.
Okay.
Yeah, I knew that.
360 divided by 5.
So listen. So I'm going to clear this out for a minute. That means if I divide that in half, this angle is 54 degrees.
Yeah.
Right here.
Yeah.
And if I form a triangle right here,
You get
and
9.
call this x, I can find the perimeter of the small pentagon. Because in reference to 54, I have the adjacent side and the hypotenuse.
Okay, so wait.
I'm doing it right now.
So did you see my triangle? I'm looking at this triangle here.
So you know that the side of 54 is half of one of the sides.
So this is 54, right?
Opposite adjacent.
And I know that I want x. So I'm going to say x is adjacent to 54, so I'm going to say the cosine of 54 is equal to the adjacent side divided by 1.
Why do you have to divide by 1?
Adjacent over hypotenuse. 1 is the radius of the circle and the hypotenuse of the triangle. Okay? So when you cross multiply and divide, x is just cosine of 54. Right? Because this is cosine of 54. And 1 times x?
0.5
About 1.6.
should be about 0.586.
587. 0.587.
Type it in the, it should be 0.58.
Right, I accidentally said one.
Oh, got it. So, this little bit here is 0.58, right? So, if you multiply it by 10, the perimeter of the inner pentagon
5 points.
is
5.87.
about 5.87.
Wait,
Okay.
times it by.
Because you need double.
Oh, we have to
X
go.
is half.
Should-
Double.
Okay, time out. Well, you want me to go for this?
Oh, it's pretty much